Let's go ahead and start this video with problem number 15. Using 19 flavors of ice cream, how many cones with 3 different flavors can you create? If it is important to you, which flavor goes on top, middle, and bottom? Well, top, middle, bottom is telling us that you want a certain order. So like if you had chocolate, vanilla, strawberry, if you did vanilla, chocolate, strawberry, that would be a different order. And that matters. So order matters. So then it is a permutation because order matters. Permutation, we've got 19 flavors and we're selecting 3 different ones. So 19p3, using the formula, it's 19 factorial divided by 19 minus 3, which is 16 factorial. So it'll be 19 times 18 times 17 times 16 factorial. 16 factorials will cancel, so your answer is 19 times 18 times 17. Again, you could have used a permutation key on your calculator, got the correct answer. We can go ahead and either do it either way. So I'll just do 19 times 18 times 17, which is what we got doing it by hand, and that would give us 5,814. All right, very good. Number 16, we have an ice cream store sells 5 drinks, 5 sizes, 3 flavors. How many ways can order a drink? Now these are different selections. So by the fundamental, we have to solve this by the fundamental counting principle. Okay. We take the number of ways for each selection. So drinks is 5, sizes is 5, and flavors is 3, and the fundamental counting principle tells us the total number of ways of getting the number of drink sizes and flavors you multiply. So 5 times 5 is 25, times 3 is 75. So the math is pretty easy there. We can just multiply using our brain. We don't really need the calculator, but if you need to, go ahead. So again, 5 times 5 times 3 gives us a total of 75. All right, forgot to clear out the calculator. All right, that's number 16. Number 17, a health inspector visits 4 of 8 restaurants on Monday. How many ways can she pick the restaurants? Notice, she's picking the restaurants. She's not saying how many different orders of visiting the restaurant. So if she picks McDonald's, Burger King, Taco Bell, and Wendy's, if she switches around the order, Burger King, and then McDonald's, and then Wendy's, Taco Bell, in terms of picking the 4, it's still the same 4 restaurants. So order, in this case, does not matter because it's still the same 4 that she picks. So order does not matter as a combination, total of 8, and she's picking 4. So applying the combination formula, it's 8 factorial. The number on the left in the numerator factorial, 8 minus 4, left minus right is 4 factorial times the number on the right is also 4 factorial. So again, you could write those out and reduce as you can to get your answer, or simply I'll use the calculator. So we have the total is 8. We go over to math, and then we hit the math key, go over to probability using the right arrow 3 times. Order didn't matter. We said it was a combination, number 3, and we're selecting 4. So HC4 solves the problem, so we hit enter, and the calculator tells us the formula would give us 70. All right, very good. Number 18, how many different committees can be formed from 12 teachers and 43 students that the committee consists of? 4 teachers and 3 students. Again, now this one you have to do what? Teachers, and then you have to get the number of ways to get the students. When you get those 2 answers, you're going to multiply and you'll get your final answer. To get the number of teachers, to get the exact number, you have to use a combination because it's a total of 12 teachers, and for this problem we're selecting 4. Serve on the same committee, order doesn't matter, so it's a combination. For teachers, total 12, selecting 4, so 12C4. For students, same idea, different numbers, 43, selecting 3 students. So again, same committee, order doesn't matter. So total of 43C3. So we're going to evaluate each of these, the 12C4, 43C3 using the calculator, and then finally multiply the two together to get the final answer, to get the number of ways of getting the committees of 7 members, where you have 4 teachers and 3 students. So again, the first one is the number of teachers was solved 12, total 12 teachers. Order didn't matter. Go over the probability, select NCR, order doesn't matter, and we're selecting 4 teachers from 12C4, gives us 495. All right, for the students, 43 students, math. Highlight probability by using the right arrow key 3 times, and then select number 3 for NCR, and we're selecting 3 students. So for the number of students is 43C3, hit enter, we get that number 12,341 times the number of ways for the teachers, 495, and we get a very large total of 6,108,795. And that is indeed the correct answer. Number 19, a group of campers is going to occupy 6 campsites at a campground. There are 14 campsites altogether from which to choose. How many ways can the campsites be chosen? Again, whether you pick the campsite first, second, third, or the 6th one, it's going to be one of the 6 you use, so order doesn't matter, because all you're doing is choosing the 6. You're not designated differently. So in this case, order does not matter. So it is a combination. All right, we've got, for my problem, 14, total of 14, and we're selecting 6. So 14C6 is 14 factorial divided by 14 minus 6 is 8 factorial, then times the 6 factorial. You can write them out and reduce. If you don't have the combination key, most of you have the calculator. So I'll do the combinations. I'll use the calculator. Total is 14. Math. Go over to probability using the right arrow key 3 times. And then, or we said order doesn't matter. So it's a combination. So it's number 3. And we're selecting 6 campsites from a total of 14. So 14C6. Hit enter, and we get 3,003. Number 20, comedian knows 6 jokes and only tells 3 of them. If the order in which these jokes are told makes a difference, how they are received, how many different 3 joke routines are there, it specifically says order makes a difference, so order matters, so it's a permutation. We have, in this problem, a total of 6 jokes, and for this problem, he's telling 3, so it's 6P3, so it's 6 factorial divided by 6 minus 3, which is 3 factorial, so 6 times 5 times 4 times 3 factorial divided by 3 factorials cancel. 6 times 5 is 30 times 4 is 120. So I'll just do this one pencil and paper. Obviously, you can use your calculator and do 6P3 and get the same answer, which is 120. All right, very good. Number 21, a 448 lottery involves 4 numbers chosen from 1 through 48. Okay, a 332 lottery is choosing 3 from a total of 32. The order in which the numbers chosen does not matter, so each one is going to involve a combination. Which one is easier to win? Okay, we're going to find the one that will win will be the one that has a smaller number of possibilities, right? So the possibilities for the 48, order doesn't matter for both. So for the 48 lottery, it's a combination, 48 numbers all together, and you're choosing 4. So we'll do that on our calculator, get that answer. The other one, the 332 lottery, again, order doesn't matter. We got a total of 32 and we're choosing 3. So we'll do each one of those on our calculator, see which one is smaller to get the correct answer. So we've got 48 math key, and then over to probability. It's a combination, order doesn't matter. So we choose combination. For the 48, it's choosing 4 numbers. So we've got a total of, hit enter, 194,580. For the 32, choosing 3, we got a total of 32 numbers. Math key, over to probability by hitting the right arrow 3 times, choosing NCR, order doesn't matter. This time we're selecting 3 of the numbers for the 32 number lottery. That is 4,960. So definitely the 332 lottery is easier to win because there are only what? 4,960 possibilities compared to the number of possibilities for the 448, which was 194,580. Okay, and that is the correct answer. Okay, we're running out of time. We'll stop this session at problem number 21. This is your math teacher, Dr. Swears. If you need more help, send me an email through the inbox in the Canvas course through the FGCU portal. I hope you found these videos helpful. Thank you for viewing it. Keep up the good work.